Hi, welcome back to the breadboard. We've looked at the range of BrainBox's smart edge devices in a previous video, including their new BB-400, but we haven't gone into a lot of details of them as of yet. So what I want to do today is have a look at the BB-400, first of all setting it up initially to use on your network, and also getting it ready for programming, etc. And by that I mean you want to have a backup so that if you make any mistakes, especially while you're learning, you have something to roll back to, and also you know how to, or you will know how to back up and recover your firmware once you've made a lot of changes, because you wouldn't really want to have to manually reapply them all. It's also good practice to make regular backups anyway, especially if you're going to use this in any kind of operational environment, including a home automation system. Nothing worse than having something go wrong, something crashes, takes out your firmware, and you have to recreate everything from scratch. We're going to look at how to set it up, how to make some backups, and how to do a recovery. So the same process for recovery is going to be also what you would use for updating your firmware to perhaps to a later version of Raspbian. So right now Stretch has now been effectively deprecated and we have a new version, and that new version as of July 2019 is Buster. So I don't think that BrainBox has released a Buster version of the firmware yet, but it's just a matter of time. So knowing how to back up your existing system and restoring another one, or even just updating the firmware, will be very useful to know. In a separate video I will cover backing up the operational status versus the entire firmware, so that you can create a recovery package that would allow you to update the firmware to a completely different version rather than a sudo update, sudo upgrade, and then remap over your complete configuration and software. But for now, what we're going to look at is backing up the entire machine. Now, the core of the BrainBox BB-400 is a Raspberry Pi Compute Module 3 Plus, and the one that comes with the BB-400 is the 32 gig version. So basically, it's the top of the range, 32 gigs of eMMC flash, and it's got a gig of RAM in it. All the other peripherals, of course, are provided by the main board inside the BB-400. So first things first, I've connected 12 volts to this. You can run this from anything from 5 to 30 volts. You can see here that the link light and web light are both flashing, which means that this is running as a hotspot, because it's got no network connectivity and it defaults to be a hotspot, so that you can actually go in and configure it. So let me just turn this off a second and we will have a quick refresher of what's inside here. To get into the BB-400 is very, very simple. All you have to do is just gently press these 4 tabs. There's 2 on one side and there are 2 on the other, and then this will slide straight out from the base. So we'll just do that. Just gently push them in a little bit. You'll feel it loosen if you gently tug. We'll go to the other side. Push those, and now we can just slide it right out. So you can see here we've got the Raspberry Pi Compute module is underneath here in its socket. We have our network connections up the top. There's 2 network interfaces. One is set up to be a LAN and one is set up to be a WAN connection. So you can have this firewalled off, and there are security features built in right from the get-go that will protect your device from remote interference. If you can obviously turn that off. We'll look at more of that in detail when we get into the operation of the unit. On the other side, we have the most prominent feature is obviously the 2 supercapacitors that provide a UPS functionality to this module. So if you lose power, it will keep it going for a little while and enable it to shut down reasonably gracefully. So the battery that you need for here is a CR1220. Just pop that in, and that will provide you a level of backup for the real-time clock that is on this daughter card. What we also have up here is a Bluetooth Wi-Fi module. So aside from the backup capability and the battery, what we can also see on this side is obviously a lot of power management devices, diodes for protection, etc., etc. We've also got the Wi-Fi and Bluetooth module up here with the antenna on the top. There is a coil for an NFC, which we've mentioned before. That functionality is not currently enabled. And we have a set of jumpers here for the RS485 interface as well. We'll talk about that in another video. Flipping on to the other side, we've got our two network interfaces, which can come up to here. And as I said, they work independently. We also have a jumper here, which allows us to put the compute module into what is commonly referred to as DFU mode or programming mode. And by flipping this jumper, you will be able to initiate backups and flash new firmware and things like that. Currently, it is set in run mode where the jumper is nearest to the compute module. So when we come to do a backup and restore, we will flip this jumper, and then we'll be able to do that. And we'll see that when you're in programming mode, the compute module will not be executing your programs. So this would be offline while you're doing backup and recovery in this way. We also on this side, let me just remove the compute module a second. We also have an Atmel ATmega 32U4 processor, which connects to some I/O devices which come out on these connectors on this side and this side for I/O. Anyway, that's pretty much everything that's in here of relevance right now that we can look at while it's open. So what I'm going to do is I'm going to close it back up again. We'll fire it up, have a quick look at the web interface and what the basic setup is, and then we will put it into programming mode, and I'll show you how to make a backup of the complete set of firmware, which includes anything that you've added to Node-RED, etc., etc., any programs you've put. Basically, it'll back up the entire 32 gig eMMC memory, and then how to restore that as well. And we're going to be using Windows for doing this process. Now, okay, BB-400 is put back together, and I've turned it back on again. You can see it's flashing the link light and the web light, meaning that it is in access point mode. So it's presenting a web interface and a Wi-Fi effectively hotspot that you can connect to initially configure this. So what I'm going to do is I've got my Microsoft Surface sitting here, and if I look on the Wi-Fi list, you will see that the BB-400 shows up, and the last four letters are the last four letters of the MAC address. So if you've got more than one BB-400 in your environment running in access point mode, then you'll be able to distinguish them. So there is the Wi-Fi. You can see here it's open. So we're just going to connect to that right now, and we just hit connect. If you connect this via one of the Ethernet ports, the uplink one, well actually probably either of them, it will connect and use DHCP and pull an IP address as well, and it would probably show up on your router as the BB-400 01 E8 anyway. But for now, we're just going to be connecting through the Wi-Fi. So this is the easiest way when you just put it on your bench and you want to do something. Okay, so once you've got the connectivity to the hotspot, which as I said would be the BB-400 dash and then the last four characters of your MAC address, should get us to a not secure, but we can just skip through that and proceed to the BB-400's web interface. All right, so here we go. Now we need to put in the username and password. So to log in, default credentials will be BB for the username, lowercase, and the password is also the last four digits of your MAC address. So in my case, 01E8. Now, obviously, in a production environment, you would change this to not be the default. So we'll just hit login, and there we go. Now we've got a set of lights, web page that is reflecting the front panel of the BB-400. So what can we do here? We have local host information. Next one is the status, which was the opening screen, and as you can see, it shows the front panel again. It's exactly the same as what's happening here. Next one is showing the I/O. So it tells us the labels for each of the I/Os. Here, the mode, whether they're input, output, or not set, or unused. Any debounce timing for them. This would all be information that would be sent to the 80 mega coprocessor that's part of the BB-400. Configure the protocols. You can also, looking up here, looks like we have clickable output. So if I turn it on, then potentially, if we look here, right now they are all turned on. If I click one of these, see, I'm affecting port 0 here. So you can test your I/O. Let's go to 7. And I'm doing that one. Next, configuring the Wi-Fi. So the default configuration is as an access point, which is set up right here. As you can see, it's on. Now you can set up Bluetooth, and you can set up a Wi-Fi client, which we will do for this. But before we do that, I will actually do a full backup and show you how to do the backup and restore. You can set up the Wi-Fi app access point and its default IP address for that access point. This is the one that came up when we first powered this on, and it's the one that I'm actually currently connected to as well. Okay, going down, we've got Bluetooth, so I've got nothing configured in Bluetooth right now. Serial port, so we can set up currently in the software for RS-232. We can change that to RS-422, RS-485 full duplex, or RS-485 half duplex. Set up the baud rate to see how fast it will go, up to 900, so just under a megabit, which is pretty good, and RS-485 is able to handle that, providing the length of the cable is not too long. Applications, so Node-RED is one of the applications that is in here. I don't know if it's already turned on. Let's just go open, and looks like it is. Slightly customized version as well. BrainBox is Node-RED, so they've customized the title at least. Yep, there you go. Same as the logging into the web interfaces for this. All right, as you can see here, there are a number of flows already pre-configured. They're turned off, so they're not executing anything at the moment, but they are already here. So you've got a serial port example, a WebSockets example, a REST example, and a Modbus example. So after we've done this video, the next one, I think I'll be coming in here and having a play with some of these. I have plenty of devices on my local network that would work for a lot of these. So let's see what's on here. No, that's pretty much it. And this is not about Node-RED right now anyway. So let me just close that off so we're not getting confused. Back to here. And the last thing is a help. So you've got supports, you've got view the command line interface configuration, and you've got a quick reset, which probably puts everything back to factory defaults. So, all right, let's get out of this right now before we start changing everything. Actually, no, what I'm going to do is I will configure the Wi-Fi to connect to my local network. Then we'll do a backup and restore. So let's turn on my Wi-Fi client. Oh, we have to turn off the hotspot to do this, and add a connection. Oaks Clan Home. Put in the password. Okay, so that's all saved, and as you can see now, the web light is back on and the link light is on and solid, which means it's not working in Wi-Fi access point anymore. It's actually connecting to my network And as you can see here, I've just reconnected to it. Now I've used the IP address that it came up with at the moment because my local cache in my PC is still thinking the IP address is the Wi-Fi IP address for the same name. Once I reboot this and the cache clears out, it should work just fine. Doesn't matter for the sake of this, so we're just going to log back in, BB for the user and 01E8 for the password. Again, I haven't changed it from its defaults. And also I've just loaded up Node-RED again, but now it's using the new local network IP address as well, as you can see. Okay, so we're now reconnected, and as you can see, everything is now working again. The web link, the web is flashing because I'm using it, and the link light is solid, meaning that I'm not using an access point. And as you can see, I'm also not connected via the LAN ports either. So this is working truly on my local network using my Wi-Fi. I do not yet have a backup of this device, and I would recommend this for anybody, is that the first thing you do is actually create a backup of the firmware so that if something like a software update goes awry, you have something to restore. So what we'll do right now is I'll set the BrainBox into programming mode, DFU mode, and we will perform a backup. So in order to do that, we've got to take it out of its cover. We have to slip that jumper from run mode to backup restore mode, and then we will also connect on the USB port which is on this device. And I've taken the cover off just here. You can see the USB port right there that we need to connect to. That should present itself as a hard drive to my Windows 10 computer. So let me just get that set up, ready to go. Once you have powered back up your device and you've got your USB cable connected and the jumper is set into flash mode, then what you should find on your computer is a universal serial bus device come up called BMC2710 boot. If you don't get this, then you may not have left your BB-400 unplugged enough. One of the things that will happen, if I just pull the power right now on this one so that you can see it happening here, right? It's got UPS alert come up, and then it's going to go to stopping. You have to wait till all the lights have gone off. It can take several minutes before that light goes off because the Linux system is shutting down and it is actually running on these internal supercapacitors. And it can take a little while for that to happen. So you got to wait for it to shut down and completely shut down. I'll have to wait for this now before you can get into programming mode. Otherwise, it won't go there. It has to be entered from a power off state. So we'll just give that a few moments now to shut down. Yeah, finally, and you just heard the PC drop the Broadcom device as well. So let's just plug this in. USB is connected, link is across, and we'll plug this in. It will start up. Pre-charge means it's charging those supercapacitors. You'll hear the PC recognize the device again, as well as seeing the lights change. Yeah, that's the USB device back again, the BCM2710 boot. Alright, so let me just stand that up there. Now on the PC, what we need to do is run the RPI boot program, which you can actually download from the rpiboot.org Foundation website. I'll provide links in the description. So we run this and it should pick up, it's sending the code, and it should set the device up as a hard drive. You'll actually get two hard drives set up. Do not format the one that comes up and says, please format me, because you will really mess it up if you do. So that's F. This is very much the same as after you've just created a drive on an SD card for the normal Raspberry Pi 2. Once you put it on there, you will often get it come up and say, we've got 2 drives here, and one of them is not accessible. Same basic idea. This is just in the EMCC flash. All right, so now you can see here a whole bunch of files. These are all basically the same as the bin file, or sorry, the visible drive that you would see on a regular Raspberry Pi SD card. So what we want to do now with this is we want to run Win32 Disk Imager. I think I have that on the desktop here somewhere. Yep, here. And we'll create a backup. So we just say yes. Now we know this drive is drive E, so that's the one we want to use. We're going to be reading, so we don't want device D, we want device E. We're going to create an image file on where? Let's just put it in my downloads. I'm going to put it in my downloads folder. And BB-400. So now we can write. Right, so you click read. Sorry, not write. Do not want to write. I only want to read by creating the backup, not restoring it. So we hit read, and it will start now creating a file. And it will probably take a few minutes. So what I'll do is I'll pause the video for the moment and come back to it once it's done. So right now it's 10:42. So we'll find out how long it takes. Now there is a guide on the brainboxes.com website under FAQs, which tells you how to create a full backup image for the BB-400, but it's a Linux-based guide, so you're using Linux commands, etc. Obviously, the initial part of it up to here is the same, but the commands you use are a little bit different. It's still RPI boot, but it's under Linux. What I'm showing you is how to do it under Windows. Okay, so we're just over an hour in, and it is now completed, and we should be able to find it in my downloads folder, and here it is, BB-400 backup, and it is 30 gigabytes. Now you can shrink this by using a program called RPI shrink, but the problem is you need a Linux system to do it, either a Debian or Raspbian or whatever, Ubuntu something. And so with Windows right now, whilst I can shrink this using probably WinZip or something to shrink it, it won't auto expand from say a 3 gigabyte file up to a 30 gig when it gets put back into the EMCC. You would have to expand it out, and some applications will do that for you, but not at runtime. Using the RPI shrink program, which is also detailed in here on the BrainBoxes website, will allow you to shrink it and have it automatically expand when you first boot up off of it once you've reflashed it. Sorry, not RPI shrink, just Pi shrink. But as I said, problem with that is that you need to use a Linux distribution to run the application to make the ISO shrink in size. Now you have to remember here too, you can't just simply unplug everything and expect it to reset when you plug back in the power again, like straight away, because it's still powered with the UPS backup capability. So you've got to give it the 5 minutes to discharge so that all the lights have gone off. At that point, then you can power it back up. Even though I've switched the jumper back into run mode, normal mode, it won't boot back up into normal mode until that light has cleared and I can do a proper cold start. Okay, it is now completely gone off. So let's plug her back in, and we should go into run mode. The network should connect. Let's stick it back in the box for now so that it sits properly. Okay, so I have shown you how to perform a full backup. It takes about an hour to a Windows PC. I was using Windows 10 in this example, and now what I've done is I've made a change to the Node-RED dashboard. I've enabled one of the flows so that I can show you it working. And what this one does, the one that I've enabled, is the REST interface that allows me to turn on and off the I/O ports that you can see right here from within Node-RED. So if I go to the actual page, you can see I can turn them all off, they will go off, and I can turn them all on, they will come on. I could do the individual ones as well. So that's running under Node-RED, and it's actually, like I said, it's the BB-400 REST flow that I just enabled and deployed. Now what I've also done is deliberately broken the cockpit page. So this is something that can happen. Maybe you're doing an update and it doesn't go quite right, or you're changing a few files and things. Anyway, I've deliberately put this thing into a broken state right now, just to be able to show you that I can recover it. Now, right now, the recovery image that I have does not have this flow enabled, and it does have a working cockpit as well. So that's just shown you that it's all working. I'm just going to open it up, put it back into flash mode, and remember, you have to give it 5 minutes from powering it off and moving the jumper to allow all the power to dissipate in the supercaps so that it actually will flip into flash mode. Then I'll power it back up again and we'll do the restore process from a previously saved image, or this could also be a virgin new piece of firmware that came from BrainBox, or the existing one that came with the box. So let's just get that done and I'll be right back. So we have to wait for at least this UPS light to go off, which probably will reflect this one here saying stopping, before we can actually power it back up and get it into DFU mode. You can change, sorry, I say DFU, also flash mode is basically the same thing. So I can change this jumper now in readiness, but it needs to be physically powered off. Okay, so the light's gone off the front, so now we know we can repower it up. And it should then present itself to Windows as a USB drive once we run the loader. So that's it powered back up again. Let's get the USB lead and plug that in. Okay, we should hear Windows any moment give me a beep to let me know that it is in the right mode for programming. Okay, there we go. So first thing you do is you need to run the RPI boot program. This actually puts it into the mode where it presents as a hard drive to Windows. So that's it there. Again, you'll get up the error message that says there's a drive that you can't read. Do not format it. And the one we want is the E drive here. So this is the one where you can grab configuration files from here too. This bbconfig YAML is what is used to set up the I/O and everything, the basic configuration of the BB-400. We want to restore this image now. So let me just cancel these files that don't want to play well with us. And we've done that, so let's fire up Win32 Disk Imager and say yes. Alright, we need to make sure we pick the right drive letter, which is E, and we'll pick the file. I didn't give it an extension when I saved it, so we just say star. And there's our BB-400 backup file that we did, 32 gigabytes of it. So we open that, and now we can write. We double check again that we picked the right drive letter, which is E, and we want to write this. So we hit write, and we confirm that yes, that's what we want to do. And now we wait, and as you can see here, it's telling me that it's about an hour and 20 minutes to do this. Now you can see it's running at about 6 megabytes a second. It's 32 gigs, so if you do the math, it's about 88 minutes in total, which is about an hour and 20, which is exactly what this is showing. So I will stop the video here, and when it's all done and dusted, I will get right back to you and show you that it's now working again. Okay, it's finally finished the write. Took an hour and 22 minutes and 57 seconds. It's all done, so just say OK. We'll detach from it. Now what we need to do is unplug the USB, unplug the power, give it its few minutes for the batteries to discharge. We will set the jumper back to normal mode. And when it's all done, you should be able to power it up and it'll work as normal with the Wi-Fi working, but without the no-dread flow being enabled, because if you remember, I disabled that. It was disabled. If you remember, it was disabled in the backup that I had made. And of course, the cockpit application should be working again. While we're waiting for this, I do want to just remind you that there are techniques you can use on the image file from a backup where you can shrink it considerably. I think the estimation for a 32 gig file from one of the BB-400s is you could take it from 32 gigs down to about 3 gigs, which would obviously allow it to be restored onto the BB-400 way faster than what we're currently doing right now. I don't have a file that's been shrunk at the moment. I don't have a spare Linux system laying around to do it, and I haven't found a Windows process to do it. So I'm just using the backup that I had made. Still waiting for this to go off. This is kind of a cool feature of the BB-400 in that it does have this built-in UPS. It just, when you're doing things like this, which of course you wouldn't normally do very often at all, it can be a little frustrating while you have to wait for it, even though you know that everything is turned off and you just want to get it back into normal run mode. But it's a small price to pay compared to the benefits it gives you during normal operations. And I think it takes longer to come out of programming mode to be ready to reboot than it does when it's normally running. And I think that's probably because the CPU and things is not doing a lot. Therefore, the power consumption from the UPS supercaps is nowhere near as high, so it takes longer to drain them. There we go. All right, let's power this back up and we should be operational again. Put it back in its box now because I'm not going to do that again. So we're just waiting for the LEDs for the web and link to come up. And then we should be ready to connect again. Okay, let's see what we've got. So I'll go to Node-RED to start with. Hit refresh. It should reload now. If it started up, we may have to wait a few more minutes. Yep, it's there. So we'll log into here. Remember, I had enabled the rest flow before, and as you can see now, it is disabled again, which is correct because the backup had it disabled. So there's one part. So now this page is not going to have anything in it. There's no dashboards anymore. We go to cockpit and we do a refresh. Remember, this is broken before. This has brought up the page. Let's see. BB-400 Log in. this was also broken before, and there we are. Everything's back up and running. So perfect. So you've now taken you through. I know a little bit laborious, but I wanted you to have all the details, no matter how small. We have now done a full backup of a BB-400 and a full restore of a broken BB-400, albeit deliberately broken, but you get the point. And shown you what you can, or how to go through that process. Now, what I will show you in the next video, or a future video, is how to back up some of the key files within an operational unit. So for instance, if I got a new revision of firmware, you would want to be able to back up the operational state separate to the normal firmware install so that you can bring things back in and get it running again. So this would be things like node-red flows, the YAML file from the BB-400 that would let you reconfigure all of the I/O pins, any other applications that you may have loaded, etc., etc. Now, some of these you can obviously create a script for. Some of them you just load files and follow some simple procedures. But for now, that will wrap up this video. It's probably already way too long, and I'll see you on the next one.